Which of the following has the highest boiling point? A. Dinitrogen monoxide, B. Molecular nitrogen, C. Ammonia, or D. There is not enough information to answer this question. Anytime we are asked to compare molecules and choose which is the highest or lowest in the group, there is usually some trend governed by the molecule's physical properties that we must know in order to answer the question. In this case, it is intermolecular attractions possible between adjacent molecules which are dictated by the molecule's polarity. We see that we are selecting the compound with the highest boiling point. Polar molecules have stronger intermolecular attractions which must be overcome in the transition from liquid to gas phase. Therefore, the more polar a molecule is, the higher its boiling point will be. Let us consider the Lewis structures of each choice so that we may determine which molecules, if any, possess net dipole moments. First is dinitrogen monoxide. Next is molecular nitrogen. Last is ammonia. If we remember that dipole moments point to the more negative regions in a molecule, we see that only dinitrogen monoxide and ammonia have net dipole moments and will have a higher boiling point than molecular nitrogen. Now we'll look at the different types of intermolecular attractions, discuss what types of molecules experience them, and discuss their relative strengths. The weakest type of intermolecular attraction is an induced dipole reaction. You may also hear this referred to as the van der Waals or dispersion forces. This is an interaction between two nonpolar molecules. When they are near one another, the electron cloud of one molecule induces a shift in position of the electron cloud of the neighboring molecule to maximize attractions. When this electron cloud shift occurs, an instantaneous net dipole results because the region of the molecule the electron cloud shifts away from is partially positive and the region it shifts towards is partially negative. Because molecules are constantly in motion, these instantaneous net dipoles are very short-lived and are also constantly changing, making intermolecular attractions involving induced dipole interactions weaker than those involving molecules that possess permanent net dipole moments. Next is dipole-induced dipole interaction that involves a polar molecule with a nonpolar molecule. This is stronger than an induced dipole interaction, as the permanent net dipole of the polar molecule is much better at shifting the electron cloud of the nonpolar molecule for maximum attraction. After that is dipole-dipole interaction that involves two polar molecules. Because there are permanent net dipoles on both molecules that will never change position or disappear, these are stronger than both previous attractions. The last type of intermolecular interaction is hydrogen bonding. Hydrogen bonding is a special type of dipole-dipole interaction that involves polar molecules which have hydrogen atoms bonded to nitrogen, oxygen, or fluorine. Because these three atoms are so much more electronegative than hydrogen, the partial positive and negative regions on the molecule are stronger than the partially charged regions on other polar molecules. However, it is still somewhat of a misnomer because there are no true bonds in hydrogen bonding. So the list of intermolecular interactions on this page are in increasing strength. Let's go back to our answer choices and name the types of intermolecular attractions involved in a sample of each compound. Dinitrogen monoxide has a net dipole moment, making it a polar molecule. Two of these molecules interacting would result in dipole-dipole attractions. Molecular nitrogen is completely nonpolar and would experience only dispersion forces. Ammonia is polar and would have dipole-dipole attractions, but because it has hydrogen bonded to nitrogen, it can go one further in hydrogen bond. Because hydrogen bonding is strongest intermolecular interaction of the three molecules, the correct answer is choice C.